Good afternoon, ladies and gentlemen. Welcome here at the Technical Forum at the group exhibit Hydrogen, Fuel Cells and Batteries, this year in Hanover at the fair in the year of 2015. Every 15 minutes we'll have new presentations regarding the hydrogen industry. I invite you all to come and have a seat and have some complimentary drinks on the house. There's a lovely lady walking around to serve you with the drinks. Also, I would like to say good afternoon, good morning, or good evening to our live stream viewers all around the world. For that, please, we'll now have the next topic, the selection criteria for solenoid valves in fuel cell systems. And for that, I have the representative, the CEO of the Staiger GmbH Co. KG. Please welcome with me on stage, Mr. Marc Staiger. Big hands, please.
Thank you. Also from my side, good afternoon, ladies and gentlemen. It's a pleasure to be here and to show you a little bit about our business. First of all, I will quickly show you what our company does. I will show you the different kinds of valve technologies in the market. And especially the major topic of this afternoon is the selection criteria for solenoid valves. And we will finish up with a conclusion. So first of all, about our company. The company is now 40 years old, founded in '74. Our main focus is customized solenoid valve solutions, which means we are not a mass production supplier for standard valves. The customers that come to us, they search for really specific solutions. It's like comparing if you buy a standard car from Volkswagen or if you need a certain car or race for a particular racetrack where you want to win. Nevertheless, we also produce high volume quantities, but as I said, rather specifically for one customer. Our business sectors are medical, this is our leading business sector, but also automotive, industrial solutions, water applications, and aeronautics. We have certificates for any kind of quality, and we are over there, and even more, we are focusing the European Foundation Quality Management Award. We have more than 200 patents and utility patents, which means we are really innovatively active in this global market. The location is south of Stuttgart, and we have only one location, and we have about 10 representations all over the world. Our classical valves are the so-called diving plunger valves. These represent like 99% of the valves that you can find in the market worldwide. There are two-way valves, three-way valves, four two-way valves. So we always divide this section in pure switching valves and really proportional valve. The switching valve simply opens and closes, and the proportional valve, they open according to a certain current that you want to apply. Different materials like brass, stainless steel, different port sizes, and the media is really unlimited from air to water, gases, acids, oils, and solvents of any kind. As I said, it depends on the customer. Whatever problem he has, we will find a solution to it. Pressure ranges are typically from 0 to 8 bars, but also go up to 200 bars. Our main focus, however, is the latest technology, the so-called spider valves. These valves also exist in pure switching valves, two-way, three-way, but also in real proportional valves. I have to show to you that these valves are really small. So we talk about a size about this part of my finger, 7 millimeter. These are, you can call them micro valves, and maybe you can see it here a little bit in the presentation. The difference to a diving plunger valve is that a plunger, that's the moving part. Können wir es nochmal sehen? The moving part of the valve is not a diving plunger within the coil. It's a really small flat plate down here. This is the one that's moving. And because this part is much smaller and it's much less weight, such valve is really, really fast compared to classic diving plunger valves. And the particular feature is that because it has absolutely no friction, these valves, they run forever and ever. So you have many billion switching cycles before these valves give up their function. And they're really fast, as I said, below 1 millisecond of switching time. And they are, because there's a low mass which is activated, you need low energy to operate the entire valve. So this is our core technology meanwhile. This is where we have many, many patents, and we have a lot of technical advantages compared to classic diving plunger valves. We also do complete integrated valve systems where you have sensors, where you have manual controllers, where you have filters and everything. So not only the valve, but the entire system, which we design, which we produce, and always according to customer requirements. Now, the general selection criteria for solenoid valves, of course, you need some media that you need to control. It's either gas or liquid media. So first of all, you have a physical criteria, which means, do you need a really pure switching valve, or do you need a proportional function, which is much more complicated? What kind of flow rate do you need, and what kind of leakage rate can you accept? And what's the pressure from your ambience, and what's the pressure drop that your system can accept? And what kind of switching time do you need, and not only the switching time, but how precise needs the valve to switch all over the time? The reproducibility is relevant in that case, or even noise emissions are getting more and more relevant in any kind of application, because let's talk about electric energy or hydrogen cars. You don't have a combustion engine anymore. It's really quiet in the car. The last thing you want to hear is a valve switching. So, and the same in medical applications, when the point of care situation, when the system is next to the head of a patient, you don't want any noise. Yeah? And of course, when we talk, especially when we talk about portable applications, meanwhile we have fuel cell systems that are small like this, and portable always means it needs really low energy consumption, because otherwise you can have a huge tank and then the issue is not relevant. And also lifetime, as I said, it's a question. How long should the thing run? Do you apply the valve once per month or 10,000 times per hour? It all exists. And what kind of certificates do you need? These information, they are all relevant to what kind of valve will you select afterwards. And the next thing is, what kind of media will you control actually? Is it a liquid, is it a gas? What kind of viscosity is it? And what kind of temperature, what kind of chemical resistance, and much more questions are relevant for selecting valves. Now let's get to the fuel cell systems. And generally, as you all might know, we talk about combustible or really explosive gases in most of the cases. So we really need to take care about low leakage rates. Also internally, inside your system, but especially also externally, because you don't want to have a high concentration of explosive gases around your system. But that's important because the leakage rate, as I said, is important because you need a stable operation of your fuel cell. And as I said, to eliminate the danger of too high external concentration. And also, especially again, for mobile systems, to reduce the H2 consumption at all. So because the fuel cell system is not running 24 hours all the day. So when it's in standby mode, and if you have a high leakage rate, you should not be surprised that your fuel tank system will be empty after some days. So it's also a reason why it's important to have a low leakage rate. So first example of valves within a fuel cell system is the so-called safety or shut-off valve. That's the valve that basically shuts off the entire systems or parts of it in safety functions or in safety situations. And the most important requirement in this case, because it's a safety function, it really must close in any situation. And you can think about especially automotive applications when there's a mechanical shock. Let's talk about an accident, for instance. If there's an accident, the valve must safely shut off. And even in a situation where you have a power blackout, but still you need, it's electrical system, you need power to run it. So if there's a cut for electricity, it still needs to be safely closing the system. It needs low energy consumption because this valve particularly is in any time it's activated. So it basically closes if you deactivate it. Therefore, it needs to, at the time when it's activated, it needs to use low energy. We can apply in this case a so-called current reduction in the situation where the valve is activated. And it should not cause a pressure drop or not too big pressure drop that leads to a big port size. So this is one example of valves in the fuel cell system. There's another one. This is, we always talk about the heart of the fuel cell system. It's the pressure regulator. If you talk about a dynamic fuel cell system, which reacts immediately to the, you know, if you don't have an on-off situation, but if you have if you want to control the power of the fuel cell in different degrades, then you need a pressure regulator, a proportional valve basically. And these valves are often in combination with passive or active recirculation of unused H2, which influences, again, the whole system behavior. Usually we talk about a closed loop control. And this valve needs to really react quickly because it influences directly your controller behavior. And then last but not least, you have the purge or drain valves for the result, or let's talk about water. If you get water out of the system at the end, you need to drain the water in a way that the gas stays inside the system. But this water, if you talk about automotive situation, you can have freezing temperatures and then the valve might be damaged. So you need to be sure that the valve cannot be damaged by liquid freezing inside, and additionally, it should have a defrost function. Yeah. So conclusion, there's certainly not one valve that suits all the requirements in the fuel cell system. There are so many different applications inside the fuel cell system for valves. And the valves influences directly the system performance and reliability because it's a fluidic system at all. And customer-specific solutions offer various strategic advantages. So we are basically the development partners. We work for, especially for automotive, well, for the leading companies, in terms of consulting them and developing prototypes, feasibility studies. We do everything and even preparation for full production. And we are also serial manufacturer from one single prototype to up to mass production. We talk about more than 100,000 per year without any problem. So this is, I'm finishing here to the point and giving back to you.
Yes, unfortunately we are running out of time, so I have to cut in here this time. But you can take your question to the booth, and you are located at booth number?
E69.
Correct. So thank you for your presentation, and E69 for more questions.
Thank you very much. Thank you.
In only 2 minutes' time, we'll have the next talk from Dana. Dana, metallic bipolar plates, enabler for the European Auto Stack Core stack platform. So in 2 minutes' time, the next presentation by Dana Holding.